We are revisiting finding x-intercepts again, and if you remember what that means, that just means that when I have a parabola, we know it crosses the x-axis sometimes, sometimes it doesn't, and we're going to pay attention to that also. All right, in the opening exercise here on lesson 24, we've got two methods of solving the same equation. So they're saying, hey, look, I've got standard form. It can be put in factored form. It can be put in vertex form. Clearly, if it's in factored form, it's pretty easy to solve. If it's in vertex form, you have to make your y 0 and then isolate the x's and then take the square root, and notice that you ended up, again, with the same answer. A little bit more work, but doable. The question is, if you only have vertex form, do you want to go back to standard form and then factor, or what? So real quick, using factored form, we know that x plus 1 equals 0, or x minus 3 equals 0. So therefore, x has to equal -1 or 3. Over here, y goes to 0. We're going to add 4 to both sides, and we're going to get 4 is equal to x minus 1 squared. Allows me to take the square root of both sides. When you take the square root, this is going to be our biggest problem right here. Don't forget the plus or minus 2. We're going to then add 1 and add 1. I'm going to rewrite this so it says x is equal to 1 plus or minus 2. X equals 3, or 1 minus 2 is -1. All right, so those are pretty straightforward. The question is, um, how many of these do we need to do? When we have fractions in them, it gets a little bit more difficult. However, when it's in factored form, x still equals 7 and -1. When this is in vertex form, it might not be as easy. Remember, you got to make that go to 0. And then we've got to isolate this. We're going to add 16 thirds plus 16 thirds. So we've got 16 thirds equals 1/3 x minus 3 squared. Now, in order to get rid of the 1/3, I'm going to multiply both sides by 3. Those cancel, and I'm left with 16 equals x minus 3 squared. Take the square root of both sides, and don't forget the biggest and most important part, that's plus or minus 4 plus 3 plus 3. We now know that x equals 3 plus 4 is 7, or 3 minus 4 is -1. So it's not so bad, especially if the fractions get cleared. If you wanted to, you could probably clear those right from the start. Okay, so remember, our goal was to find x-intercepts, and we've got an equation that they gave us. Now, this is kind of interesting. If y goes to 0, we've got -10 equals x minus 1 quantity squared. If you take the square root of both sides, you're going to go back, bells and whistles go off, because you can't take the square root of a negative number. And the question is, why does this happen? Well, in this case, it happens because this graph didn't actually cross the x-axis. So we don't have any real solutions. It will have imaginary solutions, which we'll talk about later. Number 9 says, write an equation that has no x-intercepts. Well, we know that y equals x minus x squared minus 25 is this thing called a difference of squares, and it has a solution. What happens if this is plus 25? Right? If y goes to 0, x squared plus 25. We're going to subtract 25 from both sides. And now if we take the square root, we're back to where we were, right? So we know that x squared plus 25 doesn't have any real solutions. All right, I'm going to trust that some of these or most of these are going to be pretty easy. Let's take a quick look, though, at number 14. Notice if y goes to 0, right, then we have either 4x plus 1 equals 0, or we have 2x minus 1 equals 0. Minus 1 gives me 4x equals negative 1. Divide by 4, we're going to end up with x equals negative 1/4. Or plus 1, 2x equals 1. If I divide by 2, I get x is equal to 1/2. So we can solve those. Those aren't any more difficult. Well, I should say they're a little more difficult because you got to do some division. You end up with fractional answers. Same thing is true with 15. Not going to take the time to work that, but you'll end up with some fractional answers, some not. Take a quick look at 19. This one's going to be, maybe I probably ought to do 17 first. So if I do 17 and y goes to 0, we're going to subtract 12, and we get negative 12 equals negative 3x plus 4 squared. We're going to have to divide by that negative 3, right? And we're going to get 4 is equal to x plus 4 squared. Now I can take that square root and almost done, aren't we? Plus or minus 2. Don't forget the plus or minus. If you do that, you'll end up with one answer instead of two. X plus 4. If I subtract 4, I get x equals negative 4 plus or minus 2, which tells me x is equal to negative 2 and negative 6. All right. For 18, it's the same thing. That just goes to 0. They've already cleared the 10, so that's not going to be a big deal. Multiplying by 4 to get rid of the fraction will help you. Let's take a quick look at 19. I would factor out a 2. X squared plus 2x plus 2. The question now is we're looking at factors of 2 that absolute can't do that, so now I have to complete the square. So I end up with 2 x squared plus 2x plus something plus 2, right? To complete the square, half of 2 is 1, 1 squared is 1. Multiply those two and subtract. So I still have 0, right, is equal to 2 times x plus 1 squared. Those subtract out plus 0. I end up with a mistake because this should have been a 4. Remember, this was inside, so I've got to put this 2 back in it when I pull it out. So this becomes plus 2, and now we're solving. As we solve this, right, we're going to subtract 2. We get negative 2 equals 2x plus 1 squared. Divide by 2. We get negative 1 equals x plus 1 squared. And this is where we have problems. When we take the square root, right, now we know we don't have solutions. This has no real solutions. So there's ways to solve these, and there's others where we have trouble solving. Okay, I don't know if I need to do any more, but let's work 26 just for fun of it. I'm going to let you pause the video and work it, and then I'll show you the work. I should have read the directions before I started because it asks us to find the vertex, not to solve. I did solve that. That looks like one we've already solved. The vertex here is -4, 12, just in case you're wondering. Let's take a look at finding the vertex, though, for 22. I know that x is going to equal 5 and -2/3. The vertex is going to have an x value where we add 5 plus -2/3 and then divide it by 2. This becomes 15/3. This becomes 13/3. Divided by 2 is multiplying by 1/2. We end up with 13/6. Pretty ugly, but we have 13/6 here. And now theoretically I can plug that back into here and find my y value. It gets pretty ugly, but if you plug that into a calculator, you get -425/36. It is doable. A lot of your fractions have, a lot of your calculators have fraction conversions for this. So it doesn't matter where, what form this is in, you can find the vertex easily in any of those forms. Lastly, in case you need it, what if it is in standard form? Remember, you have a formula that says x equals -b/2a. So your vertex is -b/2a, comma, f of -b/2a. Go ahead and try this and I'll give you the answer. And this is just to remind you that you can find your axis of symmetry, then plug it back in and find your vertex. Good luck.